Hi there, Algebra 1 Essentials. How are you today? It is delightful to be creating this video for you. I hope that you are well. And here we go. So here's a warm-up. Now I've purposefully given you like a crazy equation. So just do the best you can. Remember to simplify, then create clever cancellations, then do the same thing to both sides. Pause this video, try this warm-up, and then we'll come back and talk about it together. Go. All right. So hopefully you've had a chance to kind of dig through this a little bit, and let's see if you got the same answer that I do. So when we're solving for x, it means that we're trying to find out the value, the number that x stands for in this equation, and we have a variety of techniques of getting at that x. First of all, we have to understand that equations have two sides, and so let's create those two sides visually by just kind of creating a dotted line. Now, I still do this. I have a degree in mathematics, and I still create the dotted line. It helps. Now, when you're looking at equations, you want to first look at each side completely separately and go through the steps of simplifying this equation before you start doing some canceling. So simplification usually starts, usually will just be either distribution or combining like terms. When you see parentheses, that's distribution. So when we're looking at the left side of this equation, we have 3x minus 8 times 2x plus 3. And then on the right side, we have negative 6 times 2x plus 5. Now, it would be very tempting on the left side to try to start here. Some folks will see that 3x minus 8, they'll zero in on it, and they'll try to shove 3x and 8 together, 8, 9, 10, 11, and get 11x, or subtract and get like negative 5x, or start to subtract 3x from both sides. There's lots of things that people do because they start to panic as soon as they see something this, complicated. But let's remember that we have an order of operations. The G stands for grouping symbols, and it's what you do first. It's the first thing you do. And so notice that the 3x minus 8 doesn't involve getting rid of a grouping symbol. Grouping symbols are things like parentheses, brackets, stuff like that. And so as soon as we remember that there is an order of operations, we know that the 3x minus 8 is not where we're going to start. The place we're going to start is getting rid of the parentheses. And the way to do that is distribution. So the tricky part about this particular equation is that this 8 is sitting next to the parentheses, but also there's a negative in front. That's a small detail that you're going to want to be paying attention to, because that negative is going to distribute into those parentheses as well. Anytime there's a negative in front, you're going to want to remember to work with it as well. So because we're starting by distributing the negative 8, the 3x just comes down. We haven't done anything with it yet. And now we take this negative 8 and we distribute it onto the 2x. So we have negative 8 times 2x, or negative 16x. And then we have negative 8 times 3, or negative 24. And we have successfully cleared the parentheses on that side. Now this right side's a little bit easier. It's pretty obvious that that's a negative 6 sitting there. We're going to take the negative 6 and distribute it onto the 2 and get negative 12x. And we'll distribute this negative 6 onto this 5 and get negative 30. And we are off and running. That's our first simplification step, distribution. Now we want to think about combining like terms. We're going to look for places where we have like terms. Notice we have 3x minus 16x. Now this is still consistent with the order of operations, because the first thing we did was took care of grouping symbols, those parentheses. Then we didn't have any exponents, and so we could skip it. We did the multiplication and division. We did some multiplication and division with that grouping symbol step, and so now we are on to addition and subtraction. We're on to that last step. So 3x's minus 16x's is negative 13x. And then that negative 24 doesn't have anybody to combine with, so it just comes down. And then negative 12x minus 30 aren't like terms, and so we can't combine them. So now that we have on separate sides completely simplified, now's the time to start thinking about doing things to both sides at the same time. In other words, creating clever cancellations. So there's x's on both sides of this equation, but that's okay because you can still cancel terms that have x's. I like to cancel the x term, or the variable term, that's on the right side of the equation first. So this side we have a negative 12x, and so I'll add 12x. That's going to create the cancellation that I want. But remembering that I have to do the same thing to both sides, and I always have to keep like terms together, I'm also going to add 12. Whoops. I'm also going to add 12x to this side. Notice that I didn't line it up underneath that 24, because 24 plus 12x, you can't combine, so I'm not going to put it there. All right, I've created this cancellation here. Negative 13x's plus 12x's is like negative 1x, and we talked about this in our last video. This is in fact the same problem. Negative 24 comes down, equals the negative 30. Remember, this negative is still here. Notice that. That's got to come down too. Now then, the last video I told you that negative 1x equals negative x, and I would like for you to work with this because that's what you're going to see in your assignments. But when you're working these problems on paper, you could leave the negative 1x in if you want. It's really the same thing, and it might actually help a little bit. I don't know, you kind of decide what makes sense to you. All right, so now we have all the x's on one side. We got to get rid of that 24, yeah? So let's add 24 to both sides. That creates this cancellation, and we have negative 1x equals negative 30 plus 24. So negative 6, right? Now, here's why I left that negative 1 in front of the x. Because now it's a little bit more obvious that maybe to get rid of it, we divide by negative 1 on both sides. And this creates this cancellation, and we have x equals 6 negative 6 divided by negative 1. Well, a negative divided by a negative is positive, and 6 divided by 1 is 6. And this is very much the same thing that I talked about in the last video where I said if negative x equals negative 6, then positive x equals positive 6. It's also kind of the same thing as just dividing by a negative, like I did. These cancel, and x equals a negative divided by a negative is positive, and so you have 6. There's all kinds of ways of thinking about that. When you end up with a negative 1 or a positive 1 in front of x, you can leave it, you can drop it, but when it comes to negatives, don't forget that they're there. That's all there is to that. So the point of this warm-up is to remind you that it doesn't matter how complicated the equation gets, you can still use the steps that we have talked about before. We want to be sure we're keeping in mind the order of operations. We're going to simplify completely by distributing and by combining like terms and keeping those sides separate. And then when we're completely done simplifying, we can move into creating clever cancellations and doing the same thing to both sides. You can do this. You can definitely do this. All right, so it's time to get your notebook out and update it. Today's notes are going to be, you're going to be taking notes today. So get a page ready for today's notes. Go to the last set of notes and write yourself some questions in the left-hand column. You might have a page to write a summary on. If you do, then make sure that summary is the answer to the essential question that's up at the top of the page. So take a minute, pause this video, and update your notebook. All right, now that your notebook is all ready to go, the essential question that goes at the top of your note page is, what can you tell about equations that have strange solutions? And your topic is equations with variables on both sides and strange solutions. So that topic should go in your table of contents and along with the page number that you're writing notes on. All right, let's do this. So we've been looking at equations for a long time, and we even looked at inequalities, and there's something to tell you about them. And that's what we're going to be talking about today, strange solutions. When we solve a problem like this one here, we end up getting one solution, and here's what I mean by that. We're just going to follow the steps of dividing this thing up to two sides. We're going to look at the left side, 5n minus 7. There's nothing to simplify. Looking at the right side, 9n plus 21, nothing to simplify, and so there's no need to do any simplification. Now we're going to create clever cancellations by doing the opposite. I like to get rid of the variable term on the right side first, and so this is a positive 9n, so I will subtract 9n, but I have to make sure that I do the same thing to both sides, so I'm going to subtract 9n over here too. That creates this cancellation here. 5n's minus 9n's is negative 4n. The minus 7 comes down, and that equals 21. Okay, we're off and running. Now we're going to get rid of that 7 next, so we're going to add 7 to both sides. That creates this cancellation. We have 4n equals 21 plus 7, or 28. And then to get rid of that negative 4, we're going to divide by negative 4 on both sides. Those cancel, and we have n, excuse me, and we have n equals negative 7. See how there's one solution? N can only be negative 7 for this problem to be, for this equation to be balanced, for this statement to be true. Only one possible solution. When we looked at inequalities, we noticed that there could be a lot of solutions. But sometimes, when you're working with equations, you get some weirdness. Let me show you what I mean. So I'm going to follow the steps that we're used to, okay? Create the sides. Now, on the left side, it looks like I need to simplify because I need to distribute. So I'm going to take 3 times 2x, or 6x, and then 3 times 1, or 3, and that's going to equal 6x because there's nothing to simplify on that side. So we can't simplify anymore on the left, we can't simplify anymore or at all on the right, and so now it's time to start creating clever cancellations. And I told you before that I like to get rid of the variable term on the right first, so I'm going to go ahead and do that. I'm going to subtract 6x from both sides. Now these 6x's cancel, which completely removes everything from the right side. 6x's minus 6x's is like nothing, and so we can put a 0 there. But look at what happens with these x's on the left. 6x's minus 6x's just kind of goes away. You could put a 0 there if that helps you see, but those things cancel completely on both sides, and the plus 3 moves down. We haven't done anything wrong. We've done exactly what we're supposed to do, and now when we simplify this, 0 plus 3 is 3 equals 0. Well, that's not true. That's simply not true. This equation led us to a result that is simply not true. We did everything correctly. We distributed correctly. We got rid of the variable term on the right correctly. We created clever cancellations correctly. Everything was correct that we did, but we ended up with a ridiculous answer. So let's go back and try it again a different way. Come on, it's like really laggy. Come on. There we go. All right, let's just try it again. Let's see what happens. All right, so again, let's distribute, because obviously that's what we need to do first. 6x plus 3 equals 6x, so that is the same. Now at this step, what I did before was I subtracted 6x from both sides. Well, let's see. What happens if I instead subtract the 3 from both sides? So I'm going to subtract 3. But looking at this right side, I can't subtract 3 from 6x. They're not like terms. what if I just kind of line it up over here and I kind of try to do this anyway. So this is a cancellation here. And on this side I have 6x, so that's correct. And then on this side I have like 6x, because that wouldn't, I couldn't combine that with the -3. And maybe what I have is 6x minus 3. Yeah, that's what I have, 6x minus 3. Okay, great. So now what? Well, maybe I want to add the 3. Okay, let's add the 3, but I don't have anything to add it to over here because I can't combine 6x plus 3, so maybe I'll just, make a note of it and just keep going a little bit. These cancel. I've got 6x on this side, and then on this side I have like 6x plus 3. Well, that's the same as this. I could keep subtracting this and then adding and subtracting and adding this 3 all day long, and I would never get this thing solved. So it appears that there's still something wrong. Oh, darn it. Well, we know that we distributed correctly, so let's go back to that step. Because everything goes crazy after that. Okay, where's our divider? We have 6x plus 3 equals 6x. Okay. What if I got rid of the 6x on the left side? Let's try that. So I'm going to subtract 6x from both sides. Well, that's a little nicer because I do have something to combine with. Now these cancel, and I have 3 equals 6x minus 6x. 0. No matter what I do, even though I'm doing everything correct, I'm simplifying both sides separately, I'm distributing, I don't have to combine like terms, so I'm not worrying about that. I'm creating clever cancellations, I'm doing the same thing to both sides, and I still get ridiculousness. I either end up with 3 equals 0, which is just a lie, or I just kept moving that 3 back and forth all day long. So you know what this means? We've got an equation that has no solution. If you get an equation like this, it looks perfectly legitimate, 3 times 2x plus 1 equals 6x. That's a perfectly legitimate equation, but you start to solve it and you get craziness, like 3 equals 0, or some number equals some number that it's not, or you keep just trading terms around all over the place and you can never solve it, then what turns out is that it has no solution at all. There's no way to solve this. And so the answer is no solution. And that's going to happen every once in a while. And don't let it panic you. It's okay. Not all equations have solutions. And so this is an instance where it doesn't. Let's look at another weird thing that comes up sometimes. So here's a perfectly legitimate looking equation. 4 times x plus 2 equals 4x plus 8. Let's create our dividing line. It appears that we need to simplify on the left by distributing that 4. 4 times x is 4x. 4 times 2 is 8. And that equals 4x plus 8. Huh. Interesting. It's the same thing on both sides. All right, well, let's not panic. I'm going to go ahead and get rid of that 4x on the right. I'm going to subtract 4x, and I'm going to subtract 4x on both sides. Now, these cancel, but so do these. And so then we have 8 equals 8. Well, what do I do now? We got rid of the variables. Should I subtract 8 from both sides? I mean, that would create a cancellation and do the same thing to both sides. Well, then I get 0 equals 0, which is still true, but it's a little weird. Maybe I did something wrong, and we should start again. All right, well, the 4 times the x is definitely 4x, and the 4 times the 2 is definitely an 8. And this is our dividing line, and then we have 4x plus 8 on this side. So maybe what I need to do is subtract the 8 from both sides. Let's try that. Let's see, subtract 8, subtract 8. We got these cancel, so I have 4x on this side equals, oh my gosh, these also cancel, and I have 4x on this side. Uh-oh. What if I divide both sides by 4? That seemed like a legitimate step. I mean, we're creating a cancellation and doing the same thing to both sides, right? And now I have x equals x. What now? Notice that every time I tried to solve this, I got something that's absolutely true, like x equals x and 8 equals 8. These are absolutely true statements. I mean, there's nothing to be done. When that happens, that means that this equation can be solved with all possible numbers. There isn't a number that exists that wouldn't solve this equation. So in the last time we saw that there was no possible solution. This time we see that sometimes every single number will be a solution. So let's talk about the difference. When you have no solution, when you've solved that equation and you've done everything correctly and you get a false statement, this is false. 3 is not equal to 0. Anytime you get a false statement, no solution. In this case, what we got every time was a constantly true statement. X equals x, 8 equals 8. These things are true every single time. That means all solutions, okay? So with equations, especially ones with variables on both sides, when you end up with an answer like this is one solution. You know what the solution is. It's -7. N equals -7, done. If you end up with a false statement, there is no solution. If you end up with a kind of crazy looking always true statement, all solutions. Okay, let's do this one and see what we end up with. Making your sides, let's distribute. 3 times 2 is 6n. 3 times 4 is 12 equals, let's see, 2 times 3n is 6n. 2 times 6 is 12. Uh-oh. Well, already we can tell that no matter what we do, we're all going to get a true statement. But we could continue, and we could subtract 12 from both sides if you want. That's going to create a cancellation on both sides, and then you have 6n equals 6n. You could divide by 6 at this point if you wanted to, but no matter what you do, you're just going to get n equals n. Now, if you went the other way and you subtracted 6n from both sides at the end, the solution would be 12 equals 12. That's what you would end up with. So is this one solution, no solution, or all solutions? Well, n always equals n, and 12 always equals 12, and so these two statements are true, correct? And so this is a case of all solutions. And this is what your answer would be, all solutions. You wouldn't get a number for your answer. Your answer would be all solutions. Let's try this one. Well, let's see. On this side, we got 12x. Nothing to do. On this side, we have 4 times 3x, or 12x. 4 times -1, or -4. Oops, I forgot my equal sign. Now, what do you want to do? Shall we subtract 12x from both sides? Shall we add 4 to both sides? Either way, it would be a legitimate step. I'm going to subtract 12x from both sides. That creates this cancellation. And, oh, by the way, this one. And since we have to represent that side with some kind of number, that number is 0. Those things went away. And we have 12x minus 12x, those cancel, and then on the right side we have -4. Well, is 0 equal to -4? Nope, never. This is a false statement, and so we have no solutions. Don't panic, y'all. Sometimes things get weird, and math is weird. But if you know what you're looking at and you practice enough, you can see how the logic works. That's all I got for you. The topic, equations with variables on both sides with strange solutions, is what we were talking about. The essential question, what can you tell about equations that have strange solutions? Well, either they have no solution or all solutions, and that seems a little strange until you work with it a bit. Your practice is on Big Ideas Math. If you haven't signed up for Big Ideas Math yet, you should, because that's where the assignment is. Go back to week 1 and find the sign up for Big Ideas Math assignment and work through that. It doesn't take long, and it's where you're going to find a lot of your assignments from now on. All right, you guys, I hope you have a wonderful day. Talk to you later. Bye.